Hello students and good afternoon. So now I am doing class for class 12. The topic is relation. So in the last online class also we were doing the chapters on relation. So in that last class we did some problems and we defined three types of relations, that is reflexive, symmetric and transitive, and as well as there was another type of relation, that was equivalence relation. So now we'll do more problems on this relation from previous year's higher secondary question papers. So in order to solve these higher secondary question papers, you should know the meaning of relation. त्यो relation को माने चाहिँ याद हुनै पर्छ, अनि three types of relation के हो अनि equivalence relation के हो त्यो हामीलाई थाहा हुनै पर्छ. So I think you revise all the problems that we did so far on this chapter relation. So today we will do these questions from previous year's higher secondary question papers. Okay, let's start it. So now this question is from HS 2015. That is question number 1. Choose the correct alternative. So this question is from objective type of questions. That is number 1 is the relation R. Here the relation R is given on a set A. Yes, set A is equal to, within second bracket there are 4 numbers out there, that is 1, 2, 3, 4 is given as set A, and the relation R defined on the set A is within second bracket, within first bracket 1 comma 1, 1 is related with 1, 2 is related with 2, 4 is related with 4, 1 is related with 2, 1 is related with 3 and 2 is related with 3. So on the set A is equal to 1, 2, 3, 4 is whether it is reflexive relation, whether it is symmetric relation, whether it is transitive relation, whether it is equivalence relation, you have to check it. So which is the correct option? You have to choose the correct answer. So in order to choose this correct answer, you should know the meaning of reflexive relation, symmetric relation, transitive relation and equivalence relation. So what is reflexive relation? A relation on a set A is said to be reflexive if A comma A is related to itself, that belongs to the relation R, for all small a belong to the set A. Is that clear? So A comma A should belong to the relation R for reflexive relation. So let us check whether it is reflexive or not. Okay, so set A is equal to 1 comma 2 comma 3 comma 4 is there. तो यहाँ के हुनु पर्यो 1 कमा 1 पनि हुनु पर्छ, 2 कमा 2 पनि हुनु पर्छ, 3 कमा 3 पनि हुनु पर्यो, 4 कमा 4 पनि हुनु पर्यो. Let us check it in the relation R whether there are 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4 are there or not. You have to check it. Okay, so 1 for 1 comma 1 is there, yes, right. For 2 comma 2 is there, yes, there is. For 3 comma 3 should be there. Is there 3 comma 3? No. That means it is not reflexive relation. Is that clear now? So it is not a reflexive relation. So if it is not reflexive relation, it is not an equivalence relation. For the relation R to be equivalence relation, the relation R should be reflexive, symmetric and transitive. You know that, isn't it? So I think you know the definition of reflexive and equivalence relation. So I think you know it. You have revised it, I think. Okay. So now next, symmetric relation. What is meant by symmetric relation? A relation R on a set A is said to be symmetric relation if within bracket A comma B belongs to the relation R, implies that B comma A should belong to the relation R. If A comma B belongs to the relation R, it should imply that B comma A belongs to the relation R. So it is a symmetric relation. Okay, so now let us check it. So 1 comma 1 is there, 1 comma 1 is also there. Ulta parallel. So 1 comma 1 is there. If 2 comma 2 is there, 2 comma 2 is there. 4 comma 4 is there, 4 comma 4 is there. 1 comma 2 is there. Is there 2 comma 1? 1 comma 2 is there. If A comma B belongs to the relation R, then it should imply B comma A belongs to the relation R. If 1 comma 2 is there, 2 comma 1 should be there. Is there 2 comma 1? No, that means it is not a symmetric relation. यो symmetric relation पनि होइन. त भनेपछि reflexive पनि हैन, symmetric पनि हैन, equivalence पनि हैन, भनेपछि के हुनु पर्यो? Transitive relation. It should be transitive relation. The answer is C. But check it now. Whether it is transitive or not, let us check it, okay? So 1 comma 1 is there for transitivity. What is the definition of transitive relation? A relation R on a set A is said to be transitive relation if A comma B belongs to the relation R, and this is and symbol, right? And B comma C belongs to the relation R, it should imply A comma C belongs to the relation R for all A comma B comma C belongs to the set A. Is that clear now? A relation R on a set A is said to be transitive if A comma B belongs to the relation R and B comma C belongs to the relation R. It should imply that A comma C should belong to the relation R for all A comma B comma C belong to the set A. Is that clear? That is your definition of transitive relation. So now let us check it. If 1 comma 1 is there, there should be 1 comma something number should be there. 1 comma 1 is there, 1 comma 2 is there. That means 1 comma 2 should be there. It is here itself 1 comma 2. So it is transitive. Is that clear? Next, 2 comma 2 is there. 2 comma 2 is there. There should be 2 comma 3. Yes, it is there. 2 comma 2 is there. 2 comma 3 is there. So 2 comma 3 should be there. It is there, isn't it? So it is transitive. त अब अर्को चेक गरौँ. 4 comma 4 is there, right? 4 comma 4 is there. There should be 4 comma something should be there. Is there 4 comma something? No, no need of checking it. It is transitive. Okay, no need of checking this 4 comma something. 4 comma 4 is there, but there is no relation like 4 comma something, so no need of checking this one. So it is transitive. Okay, so 1 comma 2 is there. 2 comma 1 comma 2 is there. 2 comma is also 2 comma 3 is there. 1 comma 2 is there. 2 comma 3 is there. So 1 comma 3 should be here. So 1 comma 3 is here. Is that clear? So it is transitive relation. Is that clear now? Next, 1 comma 3 is there. 3 comma something should be there. Is there 3 comma something? No. So no need of checking this one. So 1 comma 3 छ भने 3 comma something छ कि छैन पहिला चेक गर्नु. छैन भने no need of checking it. यसलाई चेक गर्नु पर्दैन. It is transitive. Automatically it is transitive. So 2 comma 3 is there. 3 comma something is not there. So no need of checking it. So it is automatically transitive. Okay, so it is a transitive relation. Is that clear now? So C is the correct answer. So I think you have understood it. Okay, so you can copy it. Now let's do the next question. So now let's do the next question, that is from HS 2016. So in this case also this question is from objective question. This is also objective type of questions. Choose the correct alternatives, and this question carries 1 mark. Okay, so number 2 is, here it is given that this IR is the set of real numbers. Real number means all defined numbers. Okay, so if the relation R over a set A is defined such that, what is the relation R here? R is equal to, within second bracket, it is an ordered pair. Within first bracket A comma B, such that this A comma B is defined as A minus B is less than 3. A minus B को difference say it should be always less than 3 for all A comma B belongs to the real numbers, all defined numbers. Okay, then the relation R is number A transitive, number B equivalence, number C reflexive, and number D symmetric. So you have to choose the correct option. So in this case also you should know the meaning of transitive, equivalence, reflexive and symmetric, then only you can choose the correct option out here. Is that clear? So here the relation R is given as, this is A comma B such that A minus B less than 3 comma A comma B belongs to the set of real numbers, right? So now let us check for transitive now. So now in this case you have to take the order pair in such a way that this A minus B should be less than 3. So in order to check the transitivity, you should know the definition, isn't it? The definition is if A comma B belongs to the relation R and B comma C belongs to the relation R, implies that A comma C belongs to the relation R. So this is the definition of transitive relation. Okay, now let us check it. Let us give the example now. So you know that 6 comma 4. Let us take 6 and 4, right? So we are checking the transitivity of this relation. Okay, now let us take two numbers as 6 and 4. 6 comma 4 such that, so this relation, so you should this 6 comma 4 should satisfy this relation A minus B less than 3. So we have taken here A is equal to 6 and B is equal to what? 4, and this A minus B should be less than 3. So this 6 comma 4 should satisfy the relation A minus B less than 3. That is 6 minus 4 is equal to, what is 6 minus 4? This is 2. This is 2, right? So which is obviously less than 3. So this is the correct relation. Okay. Now let us take another order pair with 4 comma something. So you know that 4 comma 2. Let us take 4 comma 2, right? So 4 comma 2 such that, let us take this relation. What is the value for A here? 4. And what is the value for B here? It is 2. What is A minus B? 4 minus 2 is equal to 2. It is also less than 3. This is also correct. So now 4 and 4, these are equal. So 6 comma 2 should belong to the relation R here. Yo 6 comma 2 pani yo relation ma pare bhane transitive, parena bhane not transitive. Is that clear? So now let us check for 6 comma 2 such that, now A here is 6, B here is 2. Now let us check this relation whether A minus B is less than 3 or not. If it is A minus B less than 3, so it is transitive. But if it is A minus B not less than 3, so it is not transitive. Is that clear? So what is 6 minus 2 now? 6 minus 2 is equal to 4. Is it less than 3? No. 4 is not less than 3. 4 is greater than 3. So it is wrong, right? So it is wrong. That is, 4 less than 3 is wrong. So we are not getting this relation in this case. That is 6 minus 2 is equal to 4, which is not less than 3. So this is wrong. Okay. So it is not a transitive relation. Is it transitive relation? No transitive relation. Is that clear to all of you? So your transitive relation binary. Transitive relation binary, it is not an equivalence relation. So you can discard these two options A and B. So it may be C or D. Now let us check for C. Let us check for C now. So I think you have understood it. So you can note it down. Now let us check for this C, reflexive. Okay. So we are checking for reflexive now, whether it is reflexive or not. Let us check it. Reflexive means you have to take the same number, A comma A. You will take 1, 1 comma 1, 2 comma 2, 3 comma 3, etc. Okay. So if you take A comma A, what is A minus A? A minus A is equal to 0, which is obviously less than 3. 2 minus 2 is 0, 3 minus 3 is 0, 2 by 3 minus 2 by 3 is also 0, that is also your real number. Okay, so this is correct. So A comma A belongs to the relation R. That means it is reflexive. So here this relation R is what? This is your reflexive. So we are getting it as reflexive. This might be the correct answer. This is the correct answer. C is the correct answer. Let us check whether D is correct or wrong. Let us check for symmetric. Okay. So I think you have understood it. So for reflexive, A comma A should belong to the relation R. So here A comma A belongs to the relation R because you know that A minus A is equal to 0, which is obviously less than 3. So A comma A belongs to the relation R. So it is reflexive. So this C is the correct answer. So let us check for symmetric. Okay. So ये C reflex ये C नै correct answer हुन्छ. तो D हामीले सायद check नगर्दा तर check गरौँ हामी whether it is correct or wrong. Okay. लो अब symmetric को लागि के हुनु पर्यो? Symmetric को लागि what is the definition of symmetric relation? So if A comma B belongs to the relation R, then ulta B comma A should belong to the relation R. Is that clear? Now let us check it. You know that let us take it as 3 comma, let us take B as 10, such that it should belong to the relation R. If A comma B belong to the relation R, we should take these two numbers, that is ordered pair A comma B, in such a way that this relation holds, that A minus B less than 3 holds. Okay, such that 3 minus 10 is equal to minus 7, which is obviously less than 3. Okay, so now whether 10 comma 3 belongs to the relation R or not, you have to check it. About 10 comma 3 यो relation मा पर्यो भने symmetric, परेन भने not symmetric. Okay, so now let us check for 10 comma 3, such that what is the relation here? 10 minus 3. 10 minus 3 is equal to 7. But you know that 7 is this less than 3? 7 is this less than 3? No, wrong. 7 is greater than 3. तर less than 3 चाहिँ आएन. भनेपछि के होइन यो? Symmetric होइन. 3 comma 10 belongs to the relation R, but 10 comma 3 does not belong to this relation R. So यो के भएन? Symmetric होइन. But which is the correct option in this case? C, that is reflexive relation, is the correct option in this case. So I think you have understood it. So you can copy it. Now we'll do the next problem. So now this question is from the same HS question paper, that is 2016. This is 2A number 1, and this question carries 4 marks. Okay. Now this is from the relation chapter. So 2A number 1 is a relation R is defined on the set of natural numbers IN दिएको छ यहाँ चाहिँ. Actually set of natural numbers is denoted by capital N. तर यो क्वेशनमा IN भन्दैछ, that is a natural number. What do you mean by natural number? From positive 1, positive 2, 3, 4, 5, 6, 7, 8, etc. These are all natural numbers. 0 is not a natural numbers, and negative integers are not the natural numbers. Only positive integers are natural numbers. Not 0. 0 is not a natural number. Okay? That is non-negative integers. Non-negative integers. And 0 is also not a natural number. So from positive 1 it is a natural number, that is plus 1, plus 2, 3, 4, 5, 6, etc. are all natural numbers. Okay, now here the relation R on the set of natural number is defined as this x comma y belongs to the relation R. This x comma y belongs to the relation R, which implies that this difference of x minus y is divisible by 5 for all x comma y belongs to the natural number. So here the relation between x and y is given. What is that? X minus y is always divisible by 5 for all x comma y belongs to the natural numbers. Okay, so you have to prove that R is an equivalence relation. You have to prove that R is an equivalence relation. So in order to prove that R is an equivalence relation, you have to prove that R is reflexive, R is symmetric, and R is transitive. Okay, now let us check for reflexive relation. So let us check for reflexive relation. Okay, whether it is reflexive relation or not, let us check it. So it is given that x comma y belongs to the relation R, which implies that x minus y is divisible by 5. Divisible by 5. Okay, now since this x belongs to the natural number, let us take x and x. Same for reflexive relation, x should be related to itself. X लिएको छ भने हामी x नै लिन्छौं. So therefore x comma x belongs to the relation R implies that x minus x is equal to what? It is 0. So you know that 0 is divisible by 5. So 0 is always divisible by 5. So it is correct, isn't it? So 0 is divisible by 5. Is that clear? So 0 is always divisible by 5. So what can we say about the relation R? R is a reflexive relation. So therefore R is a reflexive relation. R is a reflexive relation because you know that 0 is always divisible by 5. Okay, 1 2 3 4 आको बाद चाहिँ it is not divisible by 5. Is that clear to all of you? So okay, so R is a reflexive relation. Now अब हामी के चेक गर्छौं for symmetric relation. So now let us check for symmetric relation. Symmetric relation, right? For symmetric relation, what is the definition? So if x comma y belongs to the relation R, then y comma x should belong to the relation R. Then it is symmetric relation. Okay, so what is the definition of xy belongs to the relation R? Xy belongs to the relation R implies that x minus y is divisible by 5. Is divisible by 5. That means therefore y minus x should belong to the relation R, which implies that what happens here? If x comma y is x minus y, so what can you write about y comma x? What is y comma x here? It is y comma x, which is equal to minus is taken common, x minus y. So whether it is positive or negative, this x minus y is always divisible by 5. Since x minus y is divisible by 5, their negative sign is also divisible by 5. If 10 is divisible by 5, minus 10 is also divisible by 5, isn't it? So is divisible by 5. Is divisible by 5. So I think you have understood it. That means x comma y belongs to the relation R implies that, so this is correct, isn't it? So x comma y belongs to the relation R implies that y comma x belongs to the relation R. So what can we say about the relation R? R is a symmetric relation. So R is a symmetric relation. So R is a symmetric relation. So we have proved that R is a symmetric relation. So I think you have understood it. So you can copy it. So we have proved R is a reflexive relation and also R is a symmetric relation. So you can copy it. Now we will prove for transitive relation now. So now we will prove for transitive relation now. So let us prove for transitive relation. So now for transitive relation. So what is the definition of transitive relation? So you should take three numbers here, three natural numbers, x comma y comma z, which belongs to the natural number. Okay. So if x comma y belongs to the relation R and y comma z belongs to the relation R, then what do we write according to the definition of transitive relation? We can write down that x comma z belongs to the relation R. Okay, for all, this is the symbol for all. त फर अल लेखिरहनु पर्दैन, तिमीले यो सिम्बल लेख्दा भइहाल्छ, ठीक छ। सो फर अल x, y, z बिलोङ्स टु द नेचुरल नम्बर। इज द्याट क्लियर? सो नाउ अब हामी चेक गरौँ whether it is transitive relation or not. So in this case, therefore it is given that x, y belongs to the relation R. It implies that x minus y is divisible by 5. This is divisible by 5. Also, and y comma z also belong to the relation R. It is given y comma z also belongs to the relation R, which implies that y minus z, isn't it? Y minus z, instead of x, y is written, instead of y, z is written out here. Okay, so y minus z is also divisible by 5. It is given, is also divisible by 5. Is that clear to all of you? So I think you have understood it. So now, since x minus y is divisible by 5 and y minus z is also divisible by 5, x minus y is divisible by 5, y minus z is also divisible by 5, their addition is also divisible by 5. You know that 10 is divisible by 5 and 30 is also divisible by 5. 10 is divisible by 5 and 30 is also divisible by 5. So you add 10 and 30, what is that? 40. 40 is also divisible by 5. You know that, isn't it? So let us add these two. Therefore, x minus y plus y minus z. So in this case, x minus y plus into minus z, here y gets cancels, which is equal to x minus z, right, is also divisible by 5. Is also divisible by 5. Okay, is also divisible by 5. Is that clear now? So which implies that x comma z belongs to the relation R. So x comma z belongs to the relation R. So what can you write about the relation R in this case? So R is a transitive relation. So therefore R is a transitive. Therefore R is a transitive relation. So I think you have understood it. So we have proved that R is a reflexive relation, R is a symmetric relation, as well as R is a transitive relation. So R satisfies all these three types of relations. So R, according to definition, R is an equivalence relation. Hence R is an equivalence relation. Hence R is an equivalence relation. That is proved. So in the question it is asked to prove that R is an equivalence relation. So we have proved that R is an equivalence relation. Is that clear to all of you? So you can copy it. So now we'll do the next question. So now we'll do the next question, that is from HS 2017, and this question carries 2 marks. This is from 2 marks section, right? And this is from HS 2017. So 1A, number 1 is, if R is a relation defined as, so in this case how R is defined, it is given, that is R is equal to, within second bracket, it is an ordered pair, that is x comma y, such that x plus 3y is equal to 12 and x comma y belongs to the natural number. X and y should belong to the natural number, and the relation between x and y is x plus 3y is equal to 12. Okay, then find the domain and range of R. You have to find out the domain and range of R. I told you about the domain and range of R, isn't it? That is, I told you about the domain and range of R. That is, you take an ordered pair A comma B, that is this first element. This first element is known as what? Domain. And this set of second element, this set of first element, that belongs to the relation R. the set of the first element in this ordered pair that belongs to the relation R is known as what? Domain. I told you about this one also. And the second element of the relation R, and the second element that belongs to the relation R is known as the range of the relation R. Is that clear? So now let us do it now. So now here, what is given here? What is given here? Now this is the solution. So what is given in this case? Capital R is equal to within second bracket x comma y such that x plus 3y is equal to 12 for all x comma y belongs to the set of natural numbers. You know natural numbers from positive 1 it begins, right? Plus 1, plus 2, plus 3, plus 4, etc. Up to it goes up to plus infinity, right? So here the relation is x plus 3y is equal to 12. So let us get the values of x and y which satisfies the relation x plus 3y is equal to 12. Let us get the values of x and y which satisfy this relation x plus 3y is equal to 12. But x comma y should belong to the natural number. It should be positive integers. Okay. So now, or 3y, let us get the value for y from here. 3y is equal to 12 minus x. Or what is the value for y here? 12 minus x divided by 3. Let us make a table out here. Okay. Let us make a table out here. You should find out the ordered pair. Ordered pair, that is the values of x and y which will satisfy this relation x plus 3y is equal to 12, right? So let us make a table out here. This is x and this is y. So in this case, what should be the natural value of x here, so that after subtracting it from 12, it is completely divisible by 3. So you cannot take 0 out here. 0 is not a natural number. If you take 1, you can take 1. 12 minus 1 is 11. 11 is not divided by 3. You cannot take 1. If you take 1 as a natural number here, 12 minus 1 is 11 and 11 is not divided by 3. So that is not your natural number, isn't it? So let us take 2. 12 minus 2 is 10. 10 is not divided by 3. You won't get natural number in this case also. You can take 12. 12 minus 2 is 10. 10 divided by 3. That is not a natural number. 10 is not divided by 3, right? You can take 3 here. If you take x is equal to 3, 3 is a natural number. 12 minus 2 is 9. 9 is completely divisible by 3. So you can take here x as 9. X as 3. If you take x as 3, 3 is a natural number. X is 3. 12 minus 3 is 9. 9 is divided by 3. So 3 is a natural number here. 3 comma 3. Is that clear? Next number is यहाँ के गर्नुपर्छ नेक्स्ट नम्बर कुन चाहिँ भन्दाखेरि यो जुन चाहिँ डिनोमिनेटर 3 छ नि 3 सँग 3 जोड्नु कति हुन्छ 6. Let us take 6. Okay, so you put x is equal to 6 out here. What is 12 minus 6? 6. 6 is divisible by 3. That is 2. You can take 2 as a natural number. Is that clear now? So what will be the next number? 6 plus 3 is what? Yo 6 सँग यो 3 जोड्नु कति भयो 9. It is 9, isn't it? So if you put x is equal to 9 in this case, 12 minus 9 is 3 and 3 divided by 3 is always 1. That is also a natural number. Okay. So again, can you take another numbers? 3 plus 9 is 12 and 12 minus 12 is 0. 0 divided by 3 is 0. 0 is not a natural number. So you cannot put x is equal to 12 out here. Okay. And you cannot put more than 12 out here for the values of x. The values of x more than 12 राख्यो भने के हुन्छ सबै नेगेटिभ आउँछ. जस्तै हामीले यहाँ 15 राखेर x is equal to 15. 15 is a natural number, yes, but 12 minus 15 is minus 3 divided by 3 is minus 1. But the value for y here is minus 1. So minus 1 is not a natural number. So you cannot take y is equal to minus 1 in this case, and you cannot put x is equal to 15 in this case. अब 15 भन्दा सबै ज्यादा रहेछ सबै नेगेटिभ इन्टिजर आउँछ. That is not your natural number. So हामीले e स्टप गर्नु पर्यो. So what is the relation now? R is equal to, so what is the relation? R is equal to within second bracket. You have to write it in terms of ordered pair. What is ordered pair? X comma y, 3 comma 3. This is your 3 comma 3 comma. Which is the other one ordered pair? It is 6 comma 2. And which is the next ordered pair? 9 comma 1. So this is your 9 comma 1. So this is the relation R. Is that clear? Now you have to find out the domain of the relation R. Now let us find out domain of R. So domain of R, I told you about this domain of R. Domain of R is the set of first number that belongs to X, isn't it? That is only the first number you can take, 3 comma 6 comma 9. So 3 comma 6 comma 9 is the domain of R. Domain of R. And what is range of R? So range of R is equal to, what is it? Range of R, the second number is known as the range of R. That is 3 comma 2 comma 1. 3 comma 2 comma 1 is the range of R. So these are the answers. So I think you have understood it. So you can copy it, and this question carries 2 marks. This is from HS 2017. Now we will do the next problem. You can copy it. So now we'll do the next question, that is from HS 2018. You have to choose the correct alternatives. So this is also from the objective type of questions. So question number 1, number 8 is, let set A is equal to 1 comma 2 comma 3. It is the set of 3 positive integers, that is 1 comma 2 comma 3. And R be a relation defined on the set A such that R is equal to within second bracket 1 comma 1, 1 comma 2, 2 comma 1 is there. This R is defined as 1 is in relation with 1, 1 is in relation with 2, and 2 is in relation with 1. Then the relation R will be number A, is it reflexive? Number B, is it symmetric? Number C, is it transitive? And number D, none of these. So which is the correct option? You have to check it, okay? So what is the relation R given out here? It is 1 comma 1, 1 comma 2 and 2 comma 1 is given out here, okay? So let us check for the reflexive now. पहिला हामी reflexive check गरौँ, whether it is reflexive or not, okay? For reflexive relation, for the set A, 1 comma 2 comma 3, 1 comma 1 should be there, 1 comma 1 is there, 2 comma 2 should be there. Is there 2 comma 2? No, so it is not reflexive. And let us check for symmetric relation. You know symmetric relation, if A comma B belongs to the relation R, B comma A should belong to the relation R, okay? So 1 comma 1 is there, ela ulta banada 1 comma 1, so 1 comma 1 is itself this 1 comma 1, isn't it? So 1 comma 2 is there, 2 comma 1 is there, so it is symmetric, okay? तर यहाँ 1 comma 3, 1 comma 3, 3 comma 1 छैन भने त्यसको कुरै आएन. 1 comma 3 छैन भने तिमीले केही त्यसको कुरै गर्नु पर्दैन. It is direct symmetric relation. Is that clear? So it should be symmetric relation. Is it transitive relation? Let us check it. यदि symmetric र transitive दुईटा भन्दा none of these हुन्छ हैन. So transitive relation check गरौँ. 1 comma 1 is there, 1 comma 2 is also there. So 1 comma 2 is itself this one, so it is there 1 comma 2. Is that clear? Okay. So 1 comma 2 is there, 2 comma 1 is also there, 1 comma 1 should be there. Yes, this is 1 comma 1. Transitive हुँदैछ यो. तर 2 comma 1 is there, 2 comma 1 is there, 1 comma 2 is there, isn't it? 2 comma 1 is there, 1 comma 2 is there, 2 comma 2 should be here for transitivity. Is there 2 comma 2? No. In this case, 2 comma 1 belongs to the relation R and 1 comma 2 belongs to the relation R. So for transitivity, 2 comma 2 should belong to the relation R. 2 comma 2 should belong to the relation R. Is it there 2 comma 2 here? No, it does not belong to the R. It does not belong to the relation R. Is that clear? So it is not transitive. But it is symmetric. किनभने 1 comma 2 छ भने 2 comma 1 is there, 1 comma 1 ulta banada 1 comma 1 is there, so it is a symmetric relation. So which is the correct option in this case? So this B is the correct option. Is that clear? So it is not transitive. यो तिमीको रिफ्लेक्सिभ पनि होइन ट्रान्जिटिभ पनि होइन तर के रहेछ इट इज सिमेट्रिक रिलेसन सो बी इज द करेक्ट answer so you can copy it we'll do the next question now so now this question is from higher secondary question paper 2018 so 2a number 1 this question carries 4 marks the question is a relation R is defined on the set of natural numbers. You know natural numbers, 1, positive 1, 2, 3, 4, etc. Numbers n as follows. So R is equal to order pair x comma y. This is such that maybe this one, such that maybe this one. This means such that. Okay. This means such that. Such that is either this colon or this vertical line. That is such that. X comma y both these belong to the natural numbers n and the relation given here is 2x plus y is equal to 41. 2x plus y is equal to 41. Okay, you have to show that R is neither reflexive nor symmetric nor transitive. कुनै पनि relation satisfy गर्दैन भनेर प्रुभ गर्नुपर्छ. R is neither reflexive nor symmetric nor transitive. Okay, so now for reflexive, so this is the solution. For reflexive relation, so here the relation is given as 2x plus y is equal to 41. Okay, so here the numbers should belong to the natural numbers. Natural numbers means if 1 is there, 1 should be there, 1 comma 1. So can you check that 1 comma 1 belongs to this relation such that 2 into what is the value for x here, that is 1, plus what is the value for y, that is also 1, which is equal to 3. 2 ones are 2 plus 1 is 3, so which is not equal to 41. That means 1 comma 1 does not belong to the relation R. That means R is not reflexive. So therefore the relation R is not reflexive. The relation R is not reflexive. So यो एउटा example ले नै काफी भयो यो prove गर्नुलाई R is not reflexive. Okay, so you can copy it. So R is not reflexive in this case. Now we have to prove that R is not symmetric. So for symmetric relation, you know the definition, isn't it? For symmetric relation, if A comma B belongs to the relation R, then B comma A should belong to the relation R. Okay? Now you first find out those values of x and y such that these values of x and y will satisfy this equation 2x plus y is equal to 41. Okay? So if you put x is equal to 1 as natural number, 2 ones are 2 plus 39 is 41, isn't it? If you take x is equal to 1 and y is equal to 39. Okay, so this 1 comma 39 such that let us put these values here. 2 into 1 plus y is 39, which is equal to 2 plus 39 is equal to 41, which is correct, isn't it? So you have to prove that 39 comma 1 अब उल्टा गर्नु 39 comma 1 should belong to this relation R. If 39 comma 1 is if 39 comma 1 satisfies this relation, then it is symmetric. Okay, let us check it. Now 39 comma 1 such that now instead of x is 39, y is 1. 2 into 39 plus 2 into instead of x, you put x is equal to 39 here because we have exchanged it. Okay, now x is 39. 2 into 39 plus what is y here, that is 1, which is equal to 2 into 39 is 78. 9 2s are 18, 8, 1 3 2s are 6 plus 1 is 7 plus 1. 78 plus 1 is equal to 79, which is not equal to 41. Which is not equal to 41, isn't it? So is it symmetric relation? No. This the relation R is not symmetric relation. Therefore, R is not symmetric. R is not symmetric relation. So R is not symmetric relation because 1, 39 belongs to the relation R, but 39, 1 does not belong to the relation R. So this example proves that the relation R is not symmetric. Okay, so you can copy it. Now we will do for transitivity now. So you can copy it, note it down. So now let us check for transitive relation now. So for transitive relation, what is the definition? If A comma B belongs to the relation R and B comma C belongs to the relation R, so then what is the definition of transitive relation? If A comma B belongs to the relation R and B comma C belongs to the relation R, then A comma C should belong to the relation R. Okay, then it is transitive relation. So now let us take an example. So 2x plus y is equal to 41. So let us take here A as 20, 1, right? Because this 20, 1 will satisfy this equation, isn't it? That is 2 into 20 plus 1. You have to take the order pair in such a way that this should satisfy the relation 2x plus y is equal to 41. Okay, 2 into 20 is 40. 40 plus 1 is 41. This is correct. Okay, next one, which order pair will you take? Since this is 1 as the value for y, now the value for x will be 1. So 1, 2, 1s are 2 plus 39 is 41, isn't it? 1, 39, such that. So again you have to take the order pair in such a way that 1, something should be there, so that this ordered pair must satisfy this relation 2x plus y is equal to 41 again. That is B, C should belong to the relation R. Here B is repeated, here 1 is repeated, 1, 39. So this ordered pair must satisfy this relation 2x plus y is equal to 41. Okay, so 2 into 1 plus 39, which is equal to 2 plus 39 is equal to 41. This is also true. So now this 20, 39 should belong to this relation. Let us check it. Now 20, 39 such that 2 into, what is the value for x here? 20. This is the value for x plus, what is the value for y here? 39, which is equal to 2 20s are 40 plus 39, which is equal to what? This is your 79, isn't it? That is 2, 39 should belong to the relation R. Let us check it. Okay, such that 2 into 20, 2 into 20, 2 into here the value for x is 20, 2 into 20 plus what is the value for y here? 39. 2 20s are 40 plus 39, which is equal to 79, which is not equal to 41. So this is wrong, isn't it? That means if 20, 1 belongs to the relation R and 1, 39 belongs to the relation R, but 20, 39 does not belong to the relation R. So therefore 20, 1 belongs to the relation R and 1, 39 belongs to the relation R, but what did we see here? 20, 39 does not belong to the relation R. 20, 39 does not belong to the relation R. That means the relation R is not transitive. Therefore, the relation R is not transitive. Therefore, the relation R is not transitive. Okay? So I think you have understood it. So R is also not transitive. So hence The relation R is neither reflexive nor symmetric nor transitive. So write down. Hence, therefore, hence the relation R is neither what? Reflexive, is neither reflexive nor symmetric nor transitive. That is proved. So I think you have understood it. So you can copy it. Now we'll do the next problem. So now we'll do the next question, that is from HS 2019. The question is 1A number 2, and this question carries 2 marks, right? And this question is of 2 marks. So 1A number 2 is, let capital A is equal to, within second bracket, 1, 2, 3. Set A is the set of numbers 1, 2, 3. You have to define a relation. You have to define a relation on A which is reflexive and symmetric but not transitive. That means you have to give the example. Define a relation on A which is reflexive and symmetric but not transitive. That means you have to give an example which is, you have to give an example of the relation which is reflexive and symmetric but not transitive. You have to give the example of the relation on the set A which is reflexive and symmetric but not transitive. Okay, so here the set A is equal to 1, 2, 3. Now we have to give an example of that relation on the set A 1, 2, 3, which is reflexive and symmetric but not transitive. That should not be transitive. Okay, so let us define this relation R, which is reflexive. Reflexive means if 1, 2, 3 is there, 1 is related to 1, 2 is related with 2, 3 is related with 3, should be there. That means there should be 1, 1, 2, 2, 3, 3. If you write only these 3, it is reflexive and it will be transitive, it will be symmetric also. It will be symmetric also. 1, 1 is there, 1, 1 is also there. 2, 2 is there, 2, 2 is there. 3, 3 is there, 3, 3 is also there. It is symmetric. But if you write only these 3, it is transitive also. 1, 1 is there, but 1, something is not there. No need of checking it. It is transitive. 2, 2 is there, 2, something is not there. So it is transitive. No need of checking it. 3, 3 is there, 3, something is not there. So no need of checking it. It is transitive. Okay, if you write 1, 1, 2, 2, 3, 3, it is transitive. Okay, but it should not be transitive. That means you have to add some ordered pair here. So let us add 1, 2. If you add 1, 2, so if you add 1, 2, 1, 1 is there, 1, 2 is there. Okay, so 1, 2 is also there. 1, 1 is there. 1, 2 is there, 1, 2 is there. This is transitive, but it is not symmetric. It is transitive, but it is not symmetric. Why is it not symmetric? Because 1, 2 is there, but 2, 1 is not there. But it should be symmetric. Ta halnu paryo 2, 1. Ta yaha 2, 1 haalihalnu. 2, 1 is there. Okay? If 1, 2 is there, 2, 1 should be there to make it symmetric. The symmetric भयो. अब यो reflexive त छँदैछ, symmetric पनि भयो. अब let us check for transitive. 1, 1 is there, 1, 2 is there. So 1, 2 is itself this one. Is that clear? So it is transitive. हुँदैछ यो. फेरि पनि transitive भयो. Let us check for the one. 2, 2 is there, 2, 1 is there. 2, 2 is here in the relation. 2, 1 is also there in the relation. So 2, 1 is also there. Itself 2, 1 is itself there. So it is transitive. Okay, so 3 comma 3 is there, 3 comma something is not there, no need of checking it. Okay, it is transitive. So 1 comma 2 is there, 2 comma 1 is there, 1 comma 1 is there, 1 comma 1 is there, so it is transitive. Also 2 comma 1 is there, 2 comma 1 is there, 1 comma 2 is there, so 2 comma 2 is also here, so it is transitive. It should not be transitive. So यो पनि क्या है, रिफ्लेक्सिभ पनि भयो, सिमेट्रिक पनि भयो, ट्रान्जिटिभ पनि भयो. तर it should not be transitive. Okay, so let us put 1 comma 3 now. 1 comma 3 is there, right? So 1 comma 3 हाल्ने बित्तिकै 3 comma 1 त छैन भनेपछि यो सिमेट्रिक भएन. It should be symmetric, so you have to add 3 comma 1. Is that clear? हामीले यहाँ 1 comma 3 थप्दै छौं. 1 comma 3 थप्ने बित्तिकै यो त सिमेट्रिक भएन नि त, because 3 comma 1 should be there. So हामीले के थप्नु पर्यो, 3 comma 1 should be there. Okay, so now let us check for transitivity. अब ट्रान्जिटिभ हेरौँ त. पहिला यो रिफ्लेक्सिभ हुन्छ कि हुँदैन, 1 comma 1 2 comma 2 3 comma 3 is there, so it is reflexive. Symmetric भएको भएन, 1 comma 1 1 comma 1 is there, 2 comma 2 2 comma 2 is there, 3 comma 3 3 comma 3 is there, 1 comma 2 is there, 2 comma also is here, so it is symmetric. 1 comma 3 is there, 3 comma 1 is also there, there is symmetric, so it is reflexive and symmetric. अब ट्रान्जिटिभ हुनु भएन, फेरि हेरौँ, चेक गरौँ. 1 comma 1 is there, 1 comma 2 is there, so 1 comma 2 is itself this one, so it is transitive हुँदैछ यहाँ. Again 2 comma 2 is there, 2 comma 1 is there, 2 comma 2 is there, 2 comma 1 is there, so 2 comma 1 is also here, it is transitive. Okay, so 3 comma 3 is there, 3 comma something is not there, no need of checking it, so it is transitive. Okay, 1 comma 2 is there, 2 comma 1 is there, 1 comma 1 is here, so it is transitive. 2 comma 1 is here, 1 comma 2 is also here, 2 comma 2 is also here, it is transitive. Okay, next one is 1 comma 3 is here. Okay, 1 comma 3 is here, 3 comma 1 is also here, so 1 comma 1 is also here, it is transitive. Okay, 3 comma 1 is there, 3 comma 1 is here, 1 comma 3 is also here, so 3 comma 3 is also here, it is transitive. Is that clear? Now 2 comma 1 is here, 1 comma 3 is also here. Is there 2 comma 3? 2 comma 3 is here. 2 comma 1 is in the relation, 1 comma 3 is in the relation, but 2 comma 3 is not in the relation, that is, it is not transitive. So now I think you have understood it. That is 2 comma 1 belong to the relation R and 1 comma 3 belong to the relation R. Does 2 comma 3 belong to the relation R? 2 comma 3 is here. There is no 2 comma 3. 2 comma 1 belongs to the relation R. This one, 2 comma 1 belongs to the relation R. 1 comma 3 belongs to the relation R. But 2 comma 3 does not belong to this relation R, so it is not transitive. So you can close this second bracket. So this is an example of what? Which is reflexive and symmetric but not transitive. So I think you have understood it. So this is not your transitive. So which is an example of reflexive and symmetric. Reflexive and symmetric but not transitive. So this is the definition of the relation which is reflexive and symmetric but not transitive. So you can copy it. So now we'll do the next question. So now we'll do the next question. That is, this question is from HS 2019. Okay, and this question carries 4 marks. So let us do this problem now. 2A, number 1. This question is from HS 2019 and this question carries 4 marks. So 2a number 1 is R1 and R2 are two equivalence relation defined on the set A. Defined on the set A which is not equal to 5. That means A is an non-empty set. Here A is an non-empty set. A is an non-empty set. A is an non-empty set. So in this case it is given that R1 and R2 are two equivalence relation defined on the set A. So it is given that R1 is an equivalence relation. R1 is an equivalence relation on set A. On set A. That is since R1 is a relation on the set A, so R1 is a relation on a set A, that means R1 is a subset of A cross A. That is R1 is a subset of A cross A. And since R1 is an equivalence relation on the set A, we can write down that this R1 is a subset of A cross A. A cross A एउटा relation भइगयो. So since R1 is an equivalence relation on a set A, so R1 is a subset of A cross A. So in this case, since R1 is an equivalence relation, you can write down that R1 is reflexive, symmetric and transitive. Therefore, R1 is reflexive, symmetric, and what can you write? And transitive. Is that clear to all of you? Since R1 is an equivalence relation on the set A, we can write down that R1 is a subset of A cross A and R1 is reflexive, symmetric and transitive because it is an equivalence relation. Similarly, again R2 is the same case here. R2 is an equivalence relation. R2 is an equivalence relation on set A. So here also what can you write? That is R2 is a subset of A cross A. This means is a subset of, right? So R2 is a subset of A cross A. So what can you write here? Again R2, since R2 is an equivalence relation on the set A, therefore R2 is reflexive, symmetric and transitive. Okay, so therefore R2 is reflexive, symmetric and transitive. So is that clear to all of you? So you can copy it. So in the next step, what will you do now? Now you have to prove that their intersection, R1 intersection R2 is an equivalence relation also. You have to prove it. You have to prove that also R1 intersection R2 is an equivalence relation. Okay? So now we will prove it. Now first of all you have to prove that R1 intersection R2 is a reflexive relation. Then R1 intersection R2 is a symmetric relation. Then R1 intersection R2 is a transitive relation. Then only you can write down that R1 intersection R2 is an equivalence relation. Okay. So next, since R1 is a reflexive relation, since R1 and R2 both, isn't it? I mean, R1 is a reflexive relation, also R2 is a reflexive relation. Since R1 and R2 are both reflexive relation, so therefore what is the definition? So therefore A comma A should belong to the relation R1 and A comma A should also belong to the relation R2, since both are reflexive relation, isn't it? R1 is a reflexive relation, so we can write A comma A belongs to the relation R. Okay, and Since R2 is also the reflexive relation, A comma A should belong to the relation R2. Is that clear? So now which implies that this A comma A should belong to R1 intersection R2, isn't it? किनभने A comma A relation R1 मा पनि छ, A comma A relation R2 मा पनि छ. For all small a belongs to the set A. For all small a belongs to the set A. Okay? So A comma A should belong to R1 intersection R2. So I think you have understood it. That means R1 intersection R2 is a reflexive relation. किनभने यसमा A comma A दुईटै पर्दैछ. So therefore R1 intersection R2 is a reflexive relation. Is a reflexive relation. Therefore R1 intersection R2 is a reflexive relation. Okay, so now we will prove that R1 intersection R2 is a symmetric relation. Okay, you can copy it. So we have proved that R1 intersection R2 is a reflexive relation. Now we will prove that R1 intersection R2 is a symmetric relation. Okay? So now suppose A comma B belongs to the relation R1 intersection R2. Right? Suppose A comma B belongs to the relation R1 intersection R2. So what should you prove here? B comma A should belong to the relation R1 intersection R2, which implies that A comma B belongs to the relation R1. This intersection means and. You know that if A belongs to A intersection B, so this implies that A belongs to A and A belongs to B. A is common for both A and B. Is that clear? This is just like your set operation. You have done it in class 11 also. मैले तिमीलाई class 11 मा यस्तो खाले प्रुफहरु गराएको थिए हैन. A comma B belongs to R1 intersection R2 भने के हो? A comma B belongs to the relation R1 intersection means and A comma B should belong to the relation R2. Okay? So and A comma B belongs to the relation R2. Is that clear? Since R1 is symmetric, अघि नै हामीलाई दिइसकेको छ क्वेशनले. R1 symmetric हो भने B comma A should belong to the relation R1, isn't it? Which implies that B comma A belongs to the relation R1 and also R2 is a symmetric relation. So what can you write here? B comma A belongs to the relation R2. Is that clear to all of you? यहाँ के लेख्न सक्छौं हामी? Since R1 and R2 are both symmetric relation. Are both symmetric relation. किनभने यो हामीलाई क्वेशनमै दिएको छ. R1 and R2 are both symmetric relation. So we can write उल्टा लेख्न सक्छौं. B comma A belongs to the relation R1 and B comma A belongs to the relation R2, which implies that you can combine it with the help of intersection, right? So which implies that B comma A belongs to the relation R1 intersection R2. So here what did we prove here? If A comma B belongs to the relation R1 intersection R2, it implies that B comma A उल्टा भयो नि अब. B comma A belongs to the relation R1 intersection R2. That means R1 intersection R2 is symmetric. Is that clear? So you can write here, therefore R1 intersection R2 is a symmetric relation. Is a symmetric relation. Is a symmetric relation. So I think you have understood it. Okay, so we have proved that R1 intersection R2 is a symmetric relation. Now you have to prove that R1 intersection R2 is a transitive relation. Okay. So now अब हामी के प्रुभ गर्छौं R1 intersection R2 is what? It is a symmetric, it is a transitive relation. Now we have to prove that R1 intersection R2 is a transitive relation. So for transitive relation, we can write, suppose A comma B belongs to the relation R1 intersection R2 and B comma C, and B comma C belongs to the relation R1 intersection R2. So what should we prove here? हामी यहाँ के प्रुभ गर्छौं? If A comma B belongs to the relation R1 intersection R2 and B comma C belongs to the relation R1 intersection R2, you have to prove that this A comma C should belong to the relation R1 intersection R2. Prove गरेर देखाउनु पर्छ. हामीले यो प्रुभ गरेर देखाउनु पर्छ. ठीक छ? So now which implies that if A comma B belongs to the relation R1 intersection R2, what is the definition of intersection? This A comma B belongs to the relation R1 and A comma B belongs to the relation R2. You know that, isn't it? So now here we can write A comma B belongs to the relation R1. This is the definition of intersection. We have done it in class 11. Intersection गरेको थियो तिमीहरुले हैन? So A comma B belongs to the relation R1 and A comma B belongs to the relation R2. And, right? And what can you write? And similarly here also, if B comma C belongs to the relation R1 intersection R2, what does it indicate from the definition of intersection? B comma C belongs to B comma C belongs to the relation R1, not intersection. We are separating it. Since B comma C belongs to the relation R1 intersection R2, it implies that B comma C should belong to the relation R1 and B comma C should belong to the relation R2. Okay? So B comma C belongs to the relation R1 and this is AND symbol. B comma C belongs to the relation R2. ठीक छ? त अघि नै हामीले पहिला लेखिसकेका छौं the two relations R1 and R2 are transitive relation भनेर हामीले पहिला लेखिसकेका छौं. त अब हामी यो दुईटा सँगसँगै लेख्छौं. ठीक छ? यो दुईटा सँगसँगै लेखौं यहाँ. Within bracket A comma B belongs to the relation R1 and B comma C belongs to the relation R1, right? ठीक छ? यो दुईटा हामीले सँगसँगै लेख्यौं. R1 सँगसँगै लेख्यौं. And अब R2 को हामी सँगसँगै लेख्यौं. That is A comma B belongs to the relation R2. A comma B belongs to the relation R2 and this B comma C belongs to the relation R2. Is that clear to all of you? I think you have understood it. Okay? So now, since R1 is transitive, isn't it? हामीले अघि नै के लेख्थ्यौं? R1 transitive हो भनेर लेखिसकेका छौं. त R1 transitive हो भने हामी यहाँबाट के लेख्न सक्छौं? By definition, A comma C belongs to the relation R1 and also R2 is R1 is a transitive relation. R1 is a transitive relation, isn't it? R1 is a transitive relation here. If A comma B belongs to the relation R1 and B comma C belongs to the relation R1, so A comma C belongs to the relation R1. Also R2 is a transitive relation, isn't it? R2 पनि कसँग रिलेसन हो? Transitive relation नै हो भनेर अघि नै हामीले लेखिसकेका छौं. If A comma B belongs to the relation R2 and B comma C belongs to the relation R2, so by definition what can you write? A comma C should belong to the relation R2. Okay? So here you can write A comma C belongs to the relation R1 and here A comma C belongs to the relation R2. Here you can write since R1 and R2 are what? Transitive relation. Here R1 and R2 are transitive relations. Here R1 and R2 are transitive relation. Is that clear now? So which implies that if A comma C belongs to the relation R1 and A comma C belongs to the relation R2, you can combine it. So combining, we can write A comma C belongs to the relation R1 intersection R2. Is that clear now? So here we have proved that if A comma B belongs to R1 intersection, oh sorry, this one. Now this is R1 intersection R2 is a symmetric relation. So यो चाहिँ हामीले के प्रुभ गर्यौं, सिमेट्रिक रिलेसन प्रुभ गर्यौं. अहिले भर्खर यो स्टेपबाट चाहिँ हामीले के प्रुभ गर्यौं, ट्रान्जिटिभ रिलेसन. Now if A comma B belongs to the relation R1 intersection R2 and B comma C belongs to the relation R1 intersection R2, then we have proved that A comma C belongs to the relation R1 intersection R2. So this is your transitive relation, isn't it? So therefore R1 intersection R2 is a transitive relation. Is a transitive relation. So therefore R1 intersection R2 is a transitive relation. तो यो हामीले कसरी लेख्यौं भन्दाखेरि यदि A comma B belongs to R1 intersection R2 and B comma C belongs to the relation R1 intersection R2, we have proved that A comma C belongs to the relation R1 intersection R2. So this is the definition of transitive relation. So we can write down that R1 intersection R2 is a transitive relation. Is that clear to all of you? So I think I've understood it. So now since we have proved R1 intersection R2 is a reflexive relation, first case, and also we have proved that R1 intersection R2 is a symmetric relation. Also we have proved that R1 intersection R2 is a transitive relation. So we have proved all these three, reflexive, symmetric and transitive relations. So we can write down that R1 intersection R2 is an equivalence relation. So write down hence R1 intersection R2 is an equivalence relation. Is an equivalence relation. Hence R1 intersection R2 is an equivalence relation. So it is proved. So I think you have understood it. So you can copy it. Now we'll do the next problem. So now let's do this question. That is this is not for this is not from your HS higher secondary question paper. Okay, so this question is the union of two equivalence relations R1 and R2 need not be an equivalence relation. So again हामीले चाहिँ के प्रुभ गर्यौ भन्दाखेरि the intersection of two equivalence relation R1 and R2 is an equivalence relation. But in this case the union of two equivalence relation R1 and R2 need not be an equivalence relation. You have to justify your answer. So let us justify this answer with the help of an example. Okay, so let us take an example. Let set A is equal to 1, 2, 3. So let us consider two relations R1 and R2 such that both are equivalence relation. So let us consider the relation R1 and R2, but both are equivalence relation. Let us take an example here. So R1 is equal to, so R1, you should give an example here which is equivalence relation. It should be reflexive, symmetric and transitive. Okay, so it is 1, 1, 2, 2, 3, 3. This is your what? Reflexive, symmetric and transitive. Again you can add here 1, 2. Let us write here 1, 2 and 2, 1. So you know that this is reflexive, symmetric and transitive. This is an equivalence relation because 1, 1, 2, 2, 3, 3. Reflexive relation. 1, 2, 2, 1 is there. That is your symmetric relation. 1, 1 is there. 1, 2 is there. 1, 2 is itself there. So it is a transitive relation. 2, 2 is there, 2, 1 is there, 2, 1 is itself there, so it is, so this is also your transitive relation. 3, 3 is there, but 3, something is there, no need of checking it, so it is transitive relation. So this R1 is symmetric, transitive and reflexive. So this R1 is an equivalence relation. Okay, Again, you have to give example of the relation R2, which is also reflexive, symmetric, and transitive. Let us write 1, 1, 2, 2, 3, 3. This is your reflexive, symmetric, and transitive. Again, give example 2, 3, and 3, 2. Right? So this R2 is also reflexive, symmetric, and transitive. So how is it reflexive, symmetric, and transitive? 1, 1 is there, 2, 2 is there, 3, 3 is there. Okay? Now 2, 3 is there, 3, 2 is there. So it is symmetric. Is it transitive? 1, 1 is there, 1, something is not there. So no need of checking it. 2, 2 is there, 2, 3 is there. So 2, 3 is also there. So it is transitive. Okay? 3, 3 is there, 3, 2 is there, 3, 2 is itself there. So it is also transitive. So it is reflexive, symmetric, and transitive. That is, both R1 and R2 are equivalence relations. So both R1 and R2 are equivalence relations. Are equivalence relations. So in this case, we are giving an example that R1 and R2 are both equivalence relation because both of these R1 and R2 satisfies reflexive, symmetric, and transitive relations. Okay, so both R1 and R2 are equivalence relation. Now let us check whether R1 union R2 is an equivalence relation or not. But you should prove here that the union of these two relations, R1 and R2, need not be an equivalence relation. It is not necessary that it is an equivalence relation. That is, R1 union R2 is not necessary that it is an equivalence relation. R1 union R2 is not necessary that it is an equivalence relation. So let us find out R1 union R2. That means you have to write down the set that belongs to both. You have to write down the members or elements that belongs to both R1 as well as R2 or both. Okay, so 1, 1 is there, 1, 1, 2, 2, 3, 3 is there, 1, 2 is there, 2, 1 is there. Okay, 1, 1 we have written it, no need of again writing it. 2, 2 is there, 3, 3 is there, but 2, 3 is not there. You have to write it 2, 3, then you have to write 3, 2. So now let us check whether it is an equivalence relation or not. R1 union R2, whether it is an equivalence relation or not, let us check it. Okay, so 1, 1 is there, 2, 2 is there, 3, 3 is there. It is reflexive, right? Okay, also 1, 2 is there, 2, 1 is there, symmetric. 2, 3 is there, 3, 2 is there, that is also symmetric. Let us check for transitivity. Okay, so let us check for transitivity here. 1, 2 is here, 2, 3 is also here, but is there 1, 3? 1, 3 says, yeah, chaina. So it is not transitive, but it's your equivalence relation. Hoina. Is that clear to all of you? So I think you have understood it. Since here 1, 2 belongs to the relation R1 union R2, and 1, 2 belongs to the relation R1 union R2, and 2, 3 belongs to the relation R1 union R2. R1 union R2. But 1, 3. Now about 2 ko kura aena. 1, 3. Does it belong to R1 union R2? Your R1 union R2 ma 1, 3 sa. 1, 2, 2, 1, 2, 3, 3, 2. 1, 3 is not there. So it does not belong to R1 union R2. Banebachi R1 union R2. R1 union R2 is reflexive and symmetric. Is reflexive and symmetric, but not transitive. Okay, so R1 union R2 is not an equivalence relation. Is that clear? So you can write here, so you can copy it. So you can copy here So I think you have copied it. So therefore R1 union R2 is not an equivalence relation. Is not an equivalence relation. Is not an equivalence relation. So we have proved that R1 union R2 is not an equivalence relation because this R1 union R2 is reflexive and symmetric but not transitive. So it is not an equivalence relation. So hence, if R1 and R2 are both equivalence relation, but their union need not be an equivalence relation. So hence if R1 and R2 are equivalence relation, hence if R1 and R2 are equivalence relation, therefore R1 union R2, hence if R1 and R2 are equivalence relations, therefore R1 union R2 need not be an equivalence relation. Need not be an equivalence relation. So we have proved it. Okay, so we have proved that if R1 and R2 are equivalence relations, then R1 union R2 need not be an equivalence relation. So I think you have understood it. You can copy it. So this much is for today. त आज हामीले जति पनि प्रब्लम्सहरु गर्यौं यो हायर सेकेन्डरी क्वेशन पेपर्सबाट नै प्राय गरेको छौं। जति पनि हायर सेकेन्डरी क्वेशन पेपर्समा रिलेशन्स को बारेमा आएको थियो मैले सबै गरिदिए। तिमीले घरमा जस्ट रिभिजन गर्नु, ट्राई टु अन्डरस्ट्यान्ड इट। यदि तिमीले बुझेनौ भने मैले तिमीलाई कमेन्ट गर्न सक्छौ, यु क्यान कल मी अल्सो है। मैले बारम्बार भन्दैछु तिमीलाई, यदि तिमीले बुझेनौ भने मलाई कमेन्ट गर्न सक्छौ। बुझ्नु तिमीले सोध्नु पर्छ। बुझ, जहाँ बुझ्दैन तिमीले सोध्नै पर्छ, अनि मात्रै क्लियर हुन्छ। त रिलेशन्स अब मैले सकाए। अब नेक्स्ट क्लासमा वी विल स्टार्ट फंक्शन्स. We'll do different types of functions. So after that we have to do binary operations. Okay, so this much is for today.